This is a video on scientific notation and how to convert between standard form and scientific notation. Scientific notation is a way to write really big numbers or really small numbers. That makes it really convenient and easy to understand. For example, down here, we have two ways to write the same number. So here's a number in standard form. It's really big and has a lot of zeros in it. And over here is the exact same number written in scientific notation. So we can see that it's much more manageable and easy to understand. To understand the pieces of scientific notation, I have an example here. It is 8.7 times 10 to the 6th power. So scientific notation is really a product. That means it's a multiplication problem. It contains two factors. So we have this first factor here, 8.7, and that happens to be a number that is between 1 and 10. And you can see that 8.7 is in fact between 1 and 10. The other factor is a power with a base of 10. So my base is 10, and I have an exponent here of 6. So that's how I make up my scientific notation. Now we want to convert between scientific notation and standard form. So first we'll take a number in scientific notation and we will turn it into standard form. So what I want to do is understand what this really means. So first I have my first factor, which is 5 and 61/100ths times 10 to the 4th. And what 10 to the 4th really means is times 10 4 times. So let's write that out so we can really understand what it means. This really means this. Now when I'm going to take this and put it into standard form, we do know that when we multiply anything by 10, all we need to do is move the decimal point. So let's try that. We'll take our first factor, and we'll go ahead and we'll multiply it by just this first 10. And I move the decimal one time. Now I'm going to do it by one more 10, so I'm going to move it again. Again. Oopsie daisy. And one final time. I have to add in my zeros here so I have my whole number. And here I have my answer, my standard form. Let's write that out a little nicer. 56,100. So if I take 5 and 61/100ths times 10 to the 4th power, and I convert that into standard form, it's 56,100. So I can really see down here it says the exponent in the power of 10, that's this 4 right here, determines how many places to move the decimal. So we have some more examples down here. Let's try those. So I'm going to start with the 4. And remember, if there's no decimal written, it's right here at the end of the problem. And now I'm going to move that decimal place 7 times, because what this really means is 4 times 10, 7 times. So it's times 10, times 10, times 10, times 10, times 10, times 10, and times 10. So we're going to move this decimal 7 times. So 1, 2, 3, 4, 5, 6, 7. Let's fill in our zeros. And I can put some commas in there so it makes it a little nicer. And I can see that 4 times 10 to the 7th power equals 40 million in standard form. So what I'd like you to do is hit pause on this video and try to do the second problem yourself. And now we can do it together. I start off with 7 1/10. I'm going to move that decimal place 3 times. Let's do that in red. 1, 2, 3. Fill in those zeros. And my answer in standard form is 7,100. You want to be careful because just because there's a 3 here doesn't mean I'm going to have 3 zeros. It means that I move the decimal place 3 places. So in this particular problem, I will end up with just 2 zeros. So now we move down to the next one. It says 2 53/100 times 10 to the -4th power. So this is a little bit different. It's a negative exponent. It's -4. So just so we understand what that means, a negative exponent actually means that I'm dividing by 10 4 times. So up here, when I had 10 to the 3rd power, I was multiplying by 10 3 times. So when I start off with 7.1 and multiply it by 10 3 times, I get a much bigger number. But down here, I'm going to start with 2 53/100. Let's write that down. And I'm going to actually divide by 10 4 times, which means I'm going to end up with a very, very small number because I'm dividing. So I'm going to move this decimal point 4 places, not to the right, but to the left, so that I get a really small number. So 1, 2, 3, 4. Here's my new decimal. Here's my zeros. I'm going to write that again for you. So that is, we have that meter. 1, 2, 3 zeros. Then we have our 2, our 5, and our 3. So there's our final answer. And you can see that it's a much smaller number than what we started with. Let's try this last one. I'd like you to pause the video and try this one yourself. Okay, now we can do it together. I'm going to start with 8 2/10. I'm going to divide by 10 6 times. So I'm going to move that decimal place 1, 2, 3, 4, 5, 6 places. I'm going to go ahead, fill in my decimal, fill in my zeros. Remember, there's not 6 zeros just because it's a power of 6, right? It's actually going to be 5 in this case because the 8 takes up one of those places. I'm going to write that meter for you again. We'll have 5 zeros and an 8 and a 2. So again, you can see that I started off with 8 2/10, and then when I divided by 10 6 times, I end up with a very, very small number. So we went from scientific notation to standard form. Finally, we want to convert between scientific notation and standard form the opposite way. So I'm going to start here with a number in standard form, just a regular number like you're used to, and I want to write that in scientific notation. Remember that when we have a decimal that doesn't appear in our problem, it's right here at the end. Now I'm going to turn this into 2 factors. I'm going to have a number here that's between 1 and 10 times a power of 10. So I'm going to have a base and up here some exponent. So this is what my scientific notation is going to look like. So when I start moving this decimal place this direction, I have to figure out where I'm going to stop. That's the key. Remember that this first factor here needs to be between 1 and 10. So in other words, there can only be one digit to the left of the decimal. So let's move this over. It's going to be 1, 2, 3, 4, 5, 6. So right here is where I'm going to stop. because now I only have one digit to the left of the decimal. So it's going to be 4 and 92 hundredths times 10 to the 6th power. Because I moved this over 6 places in order to get the decimal in the right location. So that's why I put a 6 up here. Let's see if we can try a few more examples. All right. Again, there's no decimal here, so I know it starts here. I'm going to go ahead and count how many places I moved that over. 1, 2, 3, 4, 5. So that's going to be 5 and 44 hundredths times 10 to the 5th power because I moved it over 5 places. All right, why don't you stop the video, hit pause again, and try this one on your own. And now we'll do it together. My decimal's right here at the end. So I'm going to go ahead and count to find my exponent. 1, 2, 3, 4, 5, 6. So I will have 7. It's just 7. I don't have to write 0.0. Times 10 to the 6th power. Now you can see this last one looks a little bit different. And we know from before that I'm going to have to move this decimal the other direction. So I'm going to have to go 1, 2, 3, 4, 5 places. And I know I want to stop here because that's going to give me this first factor here of 4 1/10. And that's what I want because I'm only going to have one digit to the left of the decimal. And this number, 4 1/10, is between 1 and 10. So I know that's what I want. I know that's where I want to stop my decimal. Times 10 to the, and I have to figure out what my exponent is. So if you remember, we moved it 5 places, but I moved it 5 places to the right, which means I'm going to have a negative, a negative exponent. So my answer here, let me fix it. There we go. Our answer is going to be 4 1/10 times 10 to the negative 5th power.